Hello and welcome to another video. In this one, we're going to be showing some stuff I did at work to debug a broken cache, and I'm going to walk you through all of the process that I used to figure out what was wrong. I didn't end up fixing this, and actually it's still a little bit broken, but we'll get to that when we get to it. Anyway, let's jump into it. And so the bug is actually in Sentry Python, and I am checked out at this revision. If you want to reproduce this particular revision, you can look at the commit history of Sentry SDK /lrucache.py, and I am before this commit. This is the first attempt to fix it, which doesn't completely fix the problem. Anyway, more on that in a bit. Now for the story part. So I was scrolling through a test output from our work repository, as I do sometimes. I was almost certainly debugging something else, and I came across something that looked strange. Anyway, let me scroll through this. Yeah, this is in the process of getting fixed too. A lot of warning noise there, blah, 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 a bunch of tests passing, everything's cool. And then, nope, not the Slack error. Where is the, yeah, there's a lot of noisy stack traces here. Here it is. This is what I was looking for. There's this weird stack trace. Let me make this a little bit bigger so we can sort of see what's going on. There's a weird stack trace where the internals of LRU cache, this particular class that we're going to be looking at in a bit, has a key error while setting a value, which tells me that there's something wrong with this. Like a cache should never crash. It should literally just make things faster. But in this particular case, it looks like it's crashing. And so we should figure out why and hopefully fix the bug there. Next, I decided to take a look at the code a little bit, and from looking at the code, it was actually very obvious what was wrong, but I wanted to somehow reproduce this bug, and so that's how we get to the next part. LRU cache is basically a vendored forked version of the standard lib LRU cache, but turned into a class. The standard lib's implementation, it's not important for this, but the standard lib's implementation uses closures as storing the data instead of class. And well, actually, I think the real version that most people use is actually written in C, but there's a pure Python version in functools.py for PyPy, and I guess I wanted to use the pure Python one. I don't know why. Also, I guess so you can copy and paste it and change it like this thing attempts to do. Anyway, I was looking at this cache, and this is almost verbatim what CPython has, but this immediately caught my eye. A copy method. I'm always a little nervous when implementing copy myself because I feel like copyable things usually you're doing something a little bit strange if you have to implement copy. And this is no surprise where the bug lives, is in these two lines here. Without going into too much detail, the way this LRU cache works is it's a set of linked list nodes and then a mapping that points at each of those. And so if you look up a particular key, you'll get a linked list node, and then you'll be able to get the result. That's if it's in the LRU cache. Otherwise, you manipulate these nodes and kick out the one that, if you're at size, you kick out the oldest one, and you maintain the least recently used via this set of links. Anyway, and this structure is also circular, so that's why this list is self-referential to itself in several ways. In this case, we have a linked list node that references itself. So its previous and next is circular to itself. Anyway, implementation details. All that you need to know is that this list and this dictionary have references to each other, and this list itself is circular. And so if you're going to copy it, you need to copy both of those at the same time, and you need to repair all of the references across each other. Because if this doesn't reference these things properly, then all bets are off. You've broken the internals of this. Anyway, this implementation is buggy. Neither of these copies are correct. This is a shallow copy of the dictionary where the values are still pointing to the linked list nodes of the thing it's copying from. So are they off there? This is also a shallow copy of the root linked list node, which also has the same problem. It points to the old linked list nodes, but it also has a separate problem in that the self-referential cyclical nodes don't refer to themselves. Anyway, I looked at the code and I was like, this is immediately wrong, almost certainly the problem. I'm going to start playing with this and see if I can reproduce this key error. So I'm actually just going to, I don't want to set up all of the code here, so I'm actually just going to copy Sentry Python, Sentry SDK, LRU cache, be right here. That way we can just import it directly. There's nothing special in here. From LRU cache, import LRU cache. Now, the first thing that I tried to do is make an LRU cache, set max size. Make an LRU cache, set a value on it. So let's say hello is set to true. If we retrieve that value, we should get true back. That works great, cool. LRU cache is working. We copy it. So usually you would not call the double under method directly. You would import copy and do copy to copy, but we're cutting some corners here. If we copy this, we should be able to retrieve the value in the same way. Actually, let's set a new value. Hello. We will set it to false. And if we retrieve that value, we get false. Cool. Everything's working. Copy worked, get set works. And that's probably where the implementer stopped and didn't try anything further. Now, an unfortunate side effect of those shallow copies from above is if we go and retrieve the key from the original one that we copied from, this mutated this object, which is a no-no. This cache shouldn't influence the other one. Anyway, so this was a bug that I found while poking around in a couple minutes, and I was like, okay, I want to reproduce this key error, but I don't know how. My first thought was to do some sort of fuzzing, but I didn't want to set up a whole fuzzing infrastructure and a whole bunch of stuff. I just wanted, I already knew that I had a way to make a crash. Let's try and reproduce this exact same crash. And so for that, we need to sort of understand how the test suite runs at Sentry. We shard our backend tests because we have too many of them, and so that's why you have all of these backend tests 0 through 10. There are 11 different shards here, and we use GitHub Actions matrices to split those up. And eventually that gets passed into an environment variable, and we have a PyTest plugin that picks up, well, the environment variable is slightly different here because we manipulate it, but don't worry about that. Anyway, eventually there's this total test groups and test group environment variable. This is how we pick the shard, and then we hash the items and put them into buckets and keep a certain number. That's kind of how the test sharding works. And I wanted to basically run the set of tests in this shard 7, up until this point, which is right around this test logic.py. And I wanted to do it locally because I didn't want to do it in CI because I want to be able to debug the problem or at least understand what was going on and poke around and play with it. So what I did is I found the environment variables from this invocation. We go up to here. When we run the tests, GitHub Actions will spit out the environment variables before it runs the thing. And these are the ones that are important. Test group 7, total test groups 11. So then I took these environment variables, checked out the code at this particular revision, and I ran the same command, this make test Python CI, but I made it instead just discover the tests instead of running them all. I don't actually have Sentry cloned here, so I'm going to show you an example using a different tool. Or a different test suite. If you run just PyTest tests, it's going to run all the tests. That's not so useful. I wanted to get a list of tests that were particular to that shard of execution. That way I could run them in the same order and figure that out. And so what I did is I set my test group equals 1, total test groups equals 11 or whatever. Set those environment variables. They obviously don't do anything here because I don't have that particular plugin. But you can run PyTest in discover only mode by doing -- collect only. And by default, this gives you an output that's kind of the nested result of all of the tests, test modules and functions, etc. This isn't very useful because it doesn't help me rerun those particular sets of things. But if you pass -q, you get an almost useful output of all of the test IDs. So if we write that to a file, test list, and open that up, you can see that we basically have a list of every single test that's in that test suite. And so what I did from there is I deleted everything up until that one file name. What was it called? Test logic? No. Where? It's not important. Oh, here it is. I deleted everything after test.logic.py. So you can imagine I scrolled down in this, found test.logic.py, and then I deleted all the tests after it. I'm not gonna do that because it's not interesting. From there, I had a test list. So let's just say, I don't know, it was the top 100 tests. And so I did this, and now I have 100 tests that I want to run. From there, I could reproduce the problem that was happening here just by rerunning those particular tests. I did that by using xargs. Xargs is a utility. I made a video on it. I'm going to forget to put it in the description, but I'm going to tell you to search my channel for Anthony Wright's code xargs if you want to learn more about it. I used xargs. Basically what this does is it takes each line in this file, partitions by line, and then folds them over to positional arguments. So this will run PyTest with all of those test IDs and run them in order. And so you can see we ran 100 tests like this. And so basically I did that same thing with the Sentry test suite and all of these tests here up until the point where I knew this crash would happen and looked at it, observed it. I don't know why, I actually still don't know why there's output here, because PyTest by default eats all of the output, so I don't really understand how this snuck to standard out, or standard error. I don't know which one it is. And when I ran it locally, I didn't get any output. So I had to run with -s, which is PyTest's way of saying, show me any printed output. I, of course, don't print anything in my tests, but if we put some print in our tests, you can see that it shows up here, whereas without -s, you wouldn't get any printed output. Anyway, I used -s to run this, and lo and behold, I was able to reproduce this key error, which is great. But I don't think making a bug report on a repository where you tell them, yeah, clone this, you know, gigabyte repository with tens of thousands of commits and install this giant set of dependencies, 200, oh my god, 250 dependencies, and then run these 1,000 tests just to get this particular output here. That doesn't sound like a very helpful bug report. Not really reproducible. I mean, it is reproducible, like they could go through all those steps, but any maintainer who gets a bug report like that's gonna be like, fuck that, I'm not, screw that, we're not doing that. So instead what I want to do is take those learnings, like I was able to reproduce this problem, I now want to make it so I can reproduce that problem for someone else. And so what I did is a little bit clever. Show you, well, I'm going to show you kind of the spoilers here of how I figured this out. Basically what I did is I modified the LRU cache implementation to print a little bit of data every time it did one of the interesting operations. And so the interesting operations here are initialization. So like we make a new LRU cache, copy, we're taking one LRU cache and we're making another one, set, because it can rearrange the values, and I believe get can also rearrange the values as well. Yeah, so I basically instrumented those 4 methods to print a unique identifier for each LRU cache instance, and then what operation it did. This, and then I ran the test suite. This allowed me to figure out exactly what set of steps I could do to get a crash. It didn't necessarily help me narrow down the problem, but it allowed me to get a reproduction independent of that giant Sentry code base. I actually have that diff if you want to see, and I'll show you the bug report I made it. Come on, GitHub. What's this? Hello? Why is it not rendering? I haven't seen that before. Weird. Okay, anyway, so here's what that looks like. I basically tagged each LRU cache instance with a UUID, unique identifier. I made a little log method that wrote out to a file. This was just helpful for me to relog stuff. And then I call self.log in those places that I care about. Note that I conditionally call it in double underinit. That way it doesn't produce 2 log lines for copy, just because this particular log line was very confusing when I was reading the output. But then I just put logs there. I also put a log line if it crashed so that we knew when we got to our particular interesting case here. But then otherwise just instrumented those. And from there, I was able to make this log that I just showed you. It's actually very long because I ran several thousand tests, and so it did a whole bunch of operations. And admittedly, looking at this, it's not super obvious what's going on, but that's okay. I didn't necessarily want to narrow it down to just one particular bug, but I wanted something that was reproduced. But just having the log doesn't help people. Yeah, they're not going to manually go by hand and run each of those. Where's the fun in that? So what I did next was I wrote a little program. And it almost felt like I was doing an Advent of Code puzzle. Familiar with Advent of Code? I'm currently streaming them on YouTube, on Twitch. It's a set of programming puzzles that comes out in December, and I have done all of them so far, which is fun. Anyway, a little off topic. But I wrote myself a little Advent of Code puzzle, and yes, I used the forbidden match statement to implement this, but basically I just parsed my log file. I probably should have made my printed data a little bit cleaner so I didn't have to massage the data afterwards. But then from there, I basically just, whenever I saw a cache ID, I would build a new one, store it in this dictionary here. If I saw a set, I would call set on it. If I saw a copy, I would call a copy on it. And this was just to catch if I had any other lines that weren't possible. This actually saved my butt a few times. Honestly, I feel like match should kind of... Anyway, I could have written this as a series of ifs. Hacking it together. But with this, actually we need to do the import path, so we need to do this. Running this spins for a bit, and then we get the reproduction that we were looking for. So this allowed me to basically have an independent script reproduce the problem, spit out this crash here, and I could take this bug report to maintainers, and hopefully they could... All right, long story. Noticed the problem immediately, but wanted to get a bug report that was reproducible and had that particular crash in it. So let's show you. Let me show you the bug report that I made. So LRU cache.copy as unsound. I had already identified the bug, and so most of that investigation was just trying to get it to reproduce that crash. And yeah, again, haven't made a minimal reproduction, but I was able to get an independent reproduction. I probably could have spent a little bit more time to narrow down the minimal reproduction such that more clear what's going on, but I think it was pretty obvious that like the copies and deep copies were sharing state in disparate objects and leading to cases that should just never have happened. I also showed that same example that I showed before, where setting it to true in one cache, setting it to false in another influences the values of one cache. And then I showed my little crasher, which is pretty cool. I also found the commit that introduced the problem, so I was able to link that directly and showed the output of my particular crash here. So I was able to basically give a full reproduction, like identify the code that was the problem, and do all of that. I also mentioned the diff that I did to generate that, just so it was reproducible, as well as this. Honestly, this is more for me to record this YouTube video because it's 2 weeks later now and I'd completely forgotten where I found this, so thank you past me. I also recommended changing the LRU cache implementation. The one that was written in the CPython version that they took it from was targeted at, I think, pre-Python 3.6. And so there weren't ordered dictionary, or I mean, there were ordered dictionaries. There wasn't a built-in dict. Built-in dict was not an ordered dictionary. That's what I want to say. And so I threw together a quick LRU cache implementation that matches the interface that this was using, but uses a dictionary instead. And the nice thing about a dictionary is you don't have two sets of state that you have to coordinate with each other. And copying is trivial now. You just copy this to the other object, and you don't have to, you don't have to deep copy. You don't have to worry about circular lists. You don't have to worry about cross object stuff. Just simple, straightforward copy. And then set and get are also fairly straightforward as well. And honestly, the structure of this sort of follows the linked list, circular linked list buffer thing, the other implementation. But I find this a lot easier to understand what's going on. It's literally just a dictionary, so not hard to understand. But yeah, basically provided or proposed an alternative implementation. They claim to have fixed it in this patch. I showed that the original reproduction still happens, so it's still open. If you want to go fix it, you can, unless someone has already done it by now, by the time video comes out. Anyway, this is kind of my long-winded way of how I went about reproducing a problem, how I was able to find exactly the same test list that was running before, run it all locally, have a cool little patch that logged out exactly what was happening so that I could replay the problem later, and then wrote a little advent of code style, parse the input and perform the computation to actually reproduce the same crash here. I had fun making this bug report, and hopefully you had fun watching this video. If you have additional things you would like me to explain, leave a comment below or reach out to me on the various platforms. But thank you all for watching, and I'll see you in the next one.